Welcome everyone. Today we're going to dive into a critical, yet often overlooked pillar of plant reliability, the MRO storeroom. We're asking a fundamental question. Is your storeroom acting as reliability insurance, or is it just a source of expensive chaos? Over the next session, we'll look at how critical spares, master data, and preservation determine whether you stay online or stay stuck. Let's start with a scenario many of you know too well. A drive fails on a paper machine. The system says there are two bearings in stock. But when the technician arrives, one shelf is empty and the second box contains a rusty part with the wrong clearance code. Now, finance sees inventory value on the books, but production sees 4 days of lost revenue. This is the gap where inventory fails to become reliability. From a practitioner's perspective, inventory is not the same thing as availability. Part you can't find or a part that is degraded is functionally zero. We must understand that criticality changes the economics. Sometimes carrying a part for years is justified if the lead time is long. To manage this, we need 3 controls: clean master data, asset bills of material, and strict preservation standards. By the end of this session, you'll be able to use this deck as a roadmap. We will define the storeroom's mission, learn to classify critical spares, clean up item data, and set real policies for stocking and preservation. Finally, we'll look at the KPIs that actually drive reliability without bloating your working capital. Our first step is to see the risk clearly. We need to expose the difference between what the accounting department sees as stock and what maintenance sees as serviceable risk coverage. If you can't trust the part on the shelf, you don't actually have it. Before we solve the problem, we need to share vocabulary. MRO inventory isn't just stuff, it's the materials required to keep the plant running. Whether it's a critical spare justified by stockout consequence, a repairable item that needs tracking, or the asset BOM that connects a part to a machine, these definitions keep our department from solving different problems. The cost of a missing part is always larger than the maintenance invoice. When we lack a critical spare, the downtime exposure can dwarf the cost of the repair. Beyond that, poor storeroom management ties up working capital in duplicates, lowers maintenance quality through degraded parts, and destroys planning productivity when technicians have to search for hours. Failure doesn't just happen, it develops through a chain. It starts with a dirty item master where duplicates hide true stock. This leads to weak BOMs, uncontrolled physical flow, and eventually false availability, where the system says yes but the shelf says no. This chain ultimately ends in a stockout, or worse, installing a part that fails immediately. We can see this chaos coming if we look for the warning signs. Are your technicians walking the shelves to find parts? Are you seeing duplicate stock or a spike in emergency rush orders? Look for storage damage like rust on bearings or repairable leakage, where failed parts are just sitting in a corner without being sent for refurbishment. I want you to ask yourself these 8 questions. Don't answer with what you intend to do, but with what you can prove with evidence. For example, can your technicians identify a part without relying on the memory of one veteran storekeeper? Are your electronics stored to preservation standards? If the answer is no, the system isn't real yet. Now that we've identified the risks, let's move to section 2, building the operating model. We need a life cycle system that connects logic to physical reality, from the moment a spare is identified to the moment it's installed or repaired. This model is built on 5 core principles. First, we serve the asset. Minimizing restoration risk is more important than just getting a bulk discount. Second, every item has one unique identity. Third, condition is part of quantity. If it's rusty, it's not one. Fourth, every transaction must be closed loop. And fifth, we must optimize by class because consumables and critical spares are not the same. We call this the right 6 system. It's a 6-step discipline. Define service, classify risk, clean identity, set policy, control condition, and finally, optimize. Our objective isn't just to have the minimum inventory possible. It's to achieve the minimum total risk-adjusted cost for the plant. Step 1 is defining service. You need a storeroom service charter. This clarifies who can request parts, what the emergency access rules are, and who owns the interface between the stores and maintenance. If these roles aren't clear, the system will break during the first night shift emergency. Step 2 is classifying risk. Reliability and engineering must own this. We need an approved spare criticality register that assesses the consequence of stockout, lead times from suppliers, and whether we have any redundancy in the plant. This separates our insurance from our daily consumables. Step 3 is cleaning identity. This is the job of the master data steward. We need standardized descriptions, validated manufacturer part numbers, and most importantly, we must link these items to asset BOMs. If a planner can't find the part in the system, they can't plan the work. Step 4 is setting policy. Here, the stores and procurement teams decide on min/max levels and reorder logic based on the criticality we've already defined. We also need clear rules for when a part becomes obsolete, so we don't keep paying to store items for machines we no longer own. Step 5 is controlling condition. This is where the rubber meets the road. The storeroom supervisor ensures every receipt is inspected and labeled. We apply preservation standards like rotating shafts or controlling humidity, and we kit parts for upcoming jobs so the technicians have everything they need in one go. The final step is optimization. This shouldn't be a one-time event. We need a cross-functional board to review stockouts, emergency buys, and non-moving items. As your assets change, your inventory policy must evolve with them to stay balanced. To keep this practical, we use decision rules. For example, if an item is high consequence with a long lead time, the rule is treat it as an insurance spare and assign a technical owner. If the condition is uncertain, the rule is do not count it as available until it passes inspection. These rules prevent convenience from overriding reliability. In Section 3, we focus on making this executable. It's about connecting purchasing, stores, planning, maintenance, and finance into one controlled flow. If there's a gap between these functions, reliability is the first thing to fall through. Execution requires clear accountability. The maintenance manager defines service needs. The storeroom supervisor owns the physical status. The planner handles the demand. Reliability owns the technical specs. And procurement manages the vendors. Everyone has a role in protecting the asset. We turn intent into execution through standard work. Every item follows a life cycle, from specification and sourcing to receipt, preservation, kitting, and finally issue or repair. By standardizing these 7 steps, we make the process repeatable and less dependent on individual heroics. Controls must be specific and observable. A procedure is just a document. A control is an action like a receiving inspection that confirms a certificate of conformance or a preservation standard that requires a motor shaft to be rotated every month. These are the barriers that prevent failure. What data do we actually need? We need enough to make a better decision. That includes technical identity, links to the machine's configuration, risk data like lead times, physical status, and a history of repairs. If your item record doesn't let a technician select the right part, it's incomplete. When it comes to metrics, use measures that trigger action. Instead of just looking at total value, look at your critical spare coverage. Are your most important machines protected? Track emergency purchases as a sign of planning failure, and count condition errors as inventory inaccuracy. If the part is rusty, the count is wrong. Management cadence is how culture becomes durable. We need a daily check on stockouts and urgent receipts, a weekly meeting for kitting and planning, and a monthly review of accuracy. Quarterly and annually, we step back to look at risk coverage and overall strategy. This rhythm keeps the system alive. Technology should reinforce your discipline, not replace it. Your CMMS, ERP, and barcode systems should all talk to each other to ensure one version of the truth. When condition monitoring detects a pending failure, it should automatically trigger a check of the material demand and spare availability. Now let's look at how to apply, verify, and sustain these changes. We'll take a real case study and then build a 90-day recovery plan to get your storeroom back on track. Recall our opening case. The 2 bearings on the screen, but 0 on the shelf. The team was faced with a high-value failure, an obsolete maker number in the BOM, and a 4-day lead time. This is the moment of truth where you have to decide. Do you gamble on an unsuitable part, or do you fix the underlying system? By applying our 6-phase framework, we change the system. We define the bearing's duty, classify it as a critical spare, clean the record to include the correct clearance suffix, set a new stocking policy with quality checks, and quarantine any old, degraded stock. We're not just fixing one bearing, we're fixing the process for all bearings. Success becomes visible through specific indicators. You'll see that system quantities actually match the physical shelf, and technicians begin selecting parts based on governed specs rather than what looks right. Most importantly, consumption of a part now triggers an automatic update to the BOM and reorder logic. Let's try a tabletop exercise. Imagine a 20-year-old motor fails. You have one spare, but the OEM is gone. How do you decide if that spare is actually serviceable? Is it an insurance spare or a capital spare? What attributes need engineering approval before you swap it? These are the real-world questions our framework helps you answer. Beware of common implementation traps. The biggest one is reducing inventory by value alone without looking at risk. That's how you accidentally scrap a critical $10,000 part that protects a $1 million process. Another is open shelves without transaction discipline. If you can't track it, you can't manage it. Don't try to boil the ocean. Start with a 90-day roadmap. Spend the first 30 days baselining your accuracy and identifying your top 50 risk items. In the next 30, pilot your preservation standards and clean up those attributes. By day 90, you should be able to verify your gains and begin scaling across the rest of the plan. To get management buy-in, you need a credible business case. Balance the costs of data cleanup and preservation against the massive value of shorter restoration times and fewer emergency freight bills. Total value is the sum of avoided stockout losses and released working capital, minus the cost to sustain the system. How do you know if you're actually doing it? Use this 12-point field audit. Score only what you can see and trace. Do critical items have a technical owner? Is receiving confirming certification? Are preservation checks actually recorded? If it isn't documented and observable, it isn't happening. To synthesize, remember that the right spare is a reliability control, but the wrong inventory is just a cost. Take back 3 commitments. No item without identity, no quantity without condition, and no disposal without a cross-functional risk review. This is how you lead from the storeroom. For those who want to go deeper, I've provided a list of resources from DOE best practices to specialized MRO courses. These links are clickable in the digital version of this deck and provide deeper dives into 5S and effective spare parts management. I'd like to credit the sources of the industrial photography used throughout this presentation. These real-world images help ground our discussion in the actual environment of warehouses and machine shops where this work happens every day. I'll leave you with one final question. Can your storeroom prove the part is ready? Reliability insurance only works when a claim can be paid immediately. Make your risks visible, make your standards executable, and verify your results. Thank you.